Wavelengths. So for us, when we're talking testing equipment, wavelengths are critical. So we have different wavelengths traveling down this core. 1310, 1550, or 1650. That is the actual measurement from peak to peak. All right, now we're going to try to connect one more dot here, going to testing. Most networks are operating in these two windows. So these wavelengths have different principles while they're operating inside the glass. 1310, it's this really hyper wavelength. It's making a whole lot of bends and turns. It's going to be able to get through turns or dead ends a little bit easier. 1550, that's a little bit longer of a wavelength. It has to come to a stop, and it's taking it longer to get out of a situation. Same thing, 1650, longer. It's going to take an even greater distance for it to make these cycles. So from here to here is even a greater distance. As an operator of a network experiences errors, if there's a bad splice right here in this fiber cable, these wavelengths, they're going to lose some of the power that the laser gave to it. And if there's, let's say, a bend in this cable, our 1310 wavelength is going to go flying through there. Whereas our 1550, when it goes through there, it's coming to a halt. So our OTDRs are able to figure out, hey, there's a bend in our cable. We've got a problem. So what their technicians are going to do is there might be another 100 houses somewhere over here that's on this fiber cable. We don't want to just unplug or turn off their laser. So we send our technicians and they're going to test at a different wavelength, at 1650. So this wavelength will not interfere with those other spitballs being transmitted. It will not get in the way or disrupt all the other people on their network not having issues. I hope this was a decent rundown on wavelengths and you guys can walk away feeling a little bit better about it. Have a great day. Reach out to us if you need help.